So there are two Demorgan laws, one for the union and one for the intersection. So the first is the union law, which is A union B whole complement is equal to A complement intersection B complement. This is the first De Morgan's law for the union, and the second De Morgan's law, which is for the intersection. So if A intersection B whole complement is equal to A intersection union B intersection, right? So these are the two De Morgan's law, the set theory, and we will prove these two laws today. So let me start with the law 1, which is this. So just to prove this, as we have already discussed, that this is the equality of the sets, and we need two steps to prove this. In the first step, we will be proving that A union B complement is the subset of A complement intersection B complement. So this will be the step number 1, and then in the step number 2 we will do the reverse. That means we will prove A complement intersection B complement is the subset of A union B whole complement, and then from this statement 1 and this statement 2 we will be able to conclude the equality of this law. So let us begin with this first one. So let me take this, and I'll assume that X is an element that is belonging to A union B whole complement. So if there is an element X, it is belonging to some complement, then definitely X will not belong to the set A union B, right? So once we can say that the set is not belonging to A union B, which means X will neither belongs to A and X will not belongs to B, because it's not in the union, which means X cannot belongs to A as well as X cannot belongs to B, right? If some element which is not in A, that means the element will definitely belongs to A complement, and we have and here. Similarly here, if X is not belonging to B, then X will belongs to B complement, right? So now we'll merge this up back. So this will be X will be the element of A complement intersection B complement, because there is an and. So X is belonging to A complement as well as X is also belonging to B complement, which means X will belongs to A complement and B complement, that is A complement intersection B complement. So we had started from that X belongs to A union B complement, and we had ended up showing in that X will also belongs to A complement intersection B complement, which means that A union B complement is a subset of A complement intersection B complement, right? So this is the step number 1. We have proved that A union B complement is the subset of A complement intersection B complement. Now we need to prove this step number 2, which we can do in a complete reverse manner, like top to bottom we have proved here. We can start from this statement and we can go back, and then we will be able to prove this second statement. So let's take this. Let us assume that X is the element which is belonging to A complement intersection B complement, the left hand side of this. So which means X will belongs to A complement and X will also belongs to B complement. So now from this, if X is an element which is belonging to A complement, which means X will not belongs to A and X will also not belongs to B. So as we know that if there is an element X which is not belonging to A and the X is also not belonging to B, which means X cannot belong to their union as well. If X is not in A and X is not in B, then definitely X cannot belong to their union. And if there is an element which is not belonging to the union, then definitely X will belong to its complement. Okay, so we had started that X is an element of A complement intersection B complement, and we had concluded that X is also the element of A union B complement, which means A complement intersection B complement is a subset of A union B whole complement. So this is your statement number 1 and this is your statement number 2, and from statement number 1 and statement number 2 we can conclude that A union B intersection is equal to A intersection A complement intersection B complement, right? So this is the first De Morgan's law we have proved it. Okay, now let's start with the second De Morgan's law, which is about the intersection, that A intersection B whole complement is equal to A intersection union B intersection. Again, this is an equality, so we have to do it in 2 steps. Step number 1, that A intersection B whole complement is a subset of A complement union B complement. And the second step, just the opposite of it, that A complement union B complement is a subset of A intersection B whole complement. So we have to prove these 2 statements. I'll start with the first one. So I'll assume that X is an element which is belonging to A intersection B whole complement. So if there is an element X which is belonging to some complement, which means X cannot belong to the A intersection B by the definition of the complement. So A cannot belong to A intersection B. So if some element is not belonging to both, which means X will, it's not in both, right? It's not in both, which means X can be in A or X belongs to B but not in both, which means it is possible that X may be belonging in A or X may be belonging in B or but not in both definitely, and it is also possible that it is not belonging in both of these sets. So if we say that X is not the element of A intersection B, then there are 3 possibilities. What is the possibilities? That X is only in A, this is first possibility. Okay, X is only in A and we'll say but not in B. This is the first possibility. What is the second possibility? X is only in B but not in A. This is the second possibility. And what is the third possibility? That X is not in both. Either in A, X does not belongs to A, and even X does not belongs to B, right? So this is the condition number 3. So we are taking this condition from here. So I will write that X will not belongs to A and X will not belongs to B. Okay, I can also replace this and by or, because there are 3 conditions. Maybe first can be true, maybe second can be true, or maybe third can be true. So we will use here or. Okay, now if some element X is not belonging to A, which means X will belongs to A complement, or similarly if X is not belonging to B, which means X will belongs to its complement. And now we'll replace this or, so this will be X will belongs to A complement union B complement, right? So from where we had started that X is an element which is belonging to A intersection B whole complement, and we had concluded that X belongs to A complement union B complement, which means that A intersection B whole complement is a subset of A complement union B complement. Okay, so this is your statement number 1. Now we have to prove the statement number 2, which is just the opposite. What we have to prove? That A complement union B complement is the subset of A intersection B whole complement. Okay, we can go reverse, completely reverse, or we can do it in the same way. So let's take X is an element which is belonging to A complement union B complement. This means X will belongs to A complement or X will belongs to B complement. So if there is an X which is belonging to A complement, which means X cannot belongs to A. And so I'll replace this by and X cannot belongs to B, right? We are sure that X is not belonging to A and X is not belonging to B. Now we'll sum this up. So if X cannot belongs to A and X is not belonging to B, which means X is not belonging to A intersection B. So if there is an element X which is not belonging to A intersection B, which means X will belongs to A intersection B whole complement. So where we had started that X belongs to A complement union B complement, and we had concluded that X belongs to A intersection B complement, which means A complement union B complement is a subset of A intersection B whole complement. So this is the second step, and as we know from the step number 1 and from the step number 2, we can conclude that A intersection B whole complement is equal to A complement union B complement. This was the De Morgan's law, second De Morgan's law. Hence proof.